So good morning, good afternoon, good evening, wherever you are. Thank you for joining in to our second webinar of our short Ravenna 2021 webinar series. Today, we will learn a bit about current standardization, organization, status, and activities. So I'll provide an overview on what's going on in AES, SMPTE, and other important organizations and industry alliances. So what are the relevant standards we are talking about? Of course, it's AES67, which is the high performance audio over IP interoperability, SMPTE ST 2110, which is a suite of standards which defines the elementary essence data transport and managed IP networks. Together with 2110 is the SMPTE ST 2059, which defines an operational profile for PTP. PTP itself has received some updates last year, actually, the PTP version 2.1. The Advanced Media Workflow Association is publishing NMOS specifications, so I'll provide an update what's going on there. And finally, I will spend a few words on a relatively new initiative, IPMX, which defines an open standard framework for the Pro AV market. All right, so let's jump into the most important standards of all. First, AES67, of course. AES67, as you all know, is a standard for interoperability among various audio over IP solutions. What does that mean? Well, basically, we have a variety of different technologies or solutions available. They are all based on IP. Of course, we have further technologies and solutions like AVB. This is not based on IP, but on layer 2. So we're talking IP layer 3 here. And the pity is they can't talk to each other natively, although they are based on IP. By the way, except for Livewire and Ravenna, which have opened up the ability to interchange back in 2012 already. But AES67 is there to cure this situation. By now, all these different technologies are actually supporting AES67, so that AES67 is a very established and accepted, broadly accepted standard in the industry to interchange signals or media content, audio content directly based on IP without having to go through analog or digital connections. So the standard has been published in 2013. For an interoperability definition, we need a number of individual definitions in various functional blocks. I'm not going to explain all these different functional blocks and what has been set forth for AES67. Part of this has been done in my webinar last week, and you'll probably also be able to look up particular or dedicated webinars which talk about AES67. Particular, of course, through the Ravenna website. So basically, we have functional blocks, and AES67 has set forth some mandatory requirements which need to be implemented and fulfilled in order to work on AES67 in terms of interoperability. Details, of course, are published by the AES Standards Organization, which is AES.org, and again, also on the Ravenna website. So as it said, 2013, so the initial publication of that standard has gone through 2 revisions meanwhile, which basically were, corrections to some errors we found, some clarifications to ambiguities, and the most important message is that nothing has changed in terms of backward compatibility. So everything which has been additionally defined throughout the various revisions is fully backward compatible with the 2013, the initially published standard. The most important addition we saw in 2018 was a PIX. Well, it's not that one. Actually, PIX is a protocol implementation conformance statement. That is basically sort of an Excel sheet which summarizes all the requirements the standard sets forth, so that manufacturers can sort of self-certify or self-describe their conformance or the conformance of their implementation with the AES67 standard. And furthermore, interested parties like system integrators or end users can check the devices to what extent they actually support the mandatory or even optional requirements, features of the AES67 standard. All this is publicly available, again, AES.org. Current status of activities in the AES67 group. We are tackling a number of different topics which came up throughout the works the years before. Multicast addressing, SDP issues, homologation with ST2110 and 2059. We are discussing the introduction of stream configuration profile. And some of you might also have followed the discussion about replacement of controversial terms inside the standard, which I will highlight a bit later when I talk about SMPTE2110. Now, important work which has been done throughout the this year, actually it started last year but has been finished this year, is a report which has been worked on and produced by this group, by the AES67 group, which is on the usage of AES67 beyond local area networks. So that standard report has been published about a month ago or so. Again, it's available on the AES.org. And this, I think, or I believe, or we believe from the AES67 group, this is very important work because it discusses how AES67 can actually be deployed beyond local area network usage. I don't want to discuss the whole report, of course, in this short hour, but just to give you an overview what is covered by the report. First of all, the standard stuff at the beginning, like introduction, scope, definitions, blah blah. And then the first thing we discussed, what are the various operational environments which can be identified beyond the usage within the LAN. So a wide area network, data centers. We also discussed virtual machines and cloud service models, which are all applicable if we are discussing AES67 usage beyond LAN. We then will identify in this report problems you most likely will encounter when deploying AES67 beyond the LAN. And most of this is, of course, related to synchronization and timing. But also the packet transport poses some, trap holes, which are identified in the problems section. Further issues which you might encounter in certain situations, like net traversal, firewalls, limited transport possibilities, and so on, are also discussed. Then, of course, once we finish discussing the problems, we offer several chapters on possible solutions. Of course, the whole synchronization area is part of this solution section. Then, of course, the audio transport. How can we reliably transport audio packets across wide area network connections? Connection management might be another issue where we offer some ideas how to solve problems you might encounter. And of course, we also discuss some things we discovered which are beyond the scope of AES67, but can be helpful to know about or to secure or to make a reliable AES67 transport across certain wide area environments. Conclusion and references are also in place, and actually the references, the annexes are the most important part of the document, I would say, because we have 6 different practical references from BBC, CBC, Eurosport, and so on, which are described in detail. So in these references or in these annexes, we describe what problems the organizations were encountering and how they solved it, how they overcome some of these problems, and how they successfully deployed AES67 beyond the LAN. So a highly interesting report, and I encourage everyone who is in that topic, in that area, to just go to AES.org and download that report. It's for free. What else is going on in AES67 and in AES work in general? The AES70 task group is still active. That's based on the open control architecture. Basically, it's a a protocol which tackles command and connection management, device control, and so these guys are further advancing their existing work, and at the moment they are tackling AES74, AES67 connection management, and also very important is NMOS convergence. I'll tackle NMOS a bit later in the presentation. Another important piece of work is executed in the X242 working group. It's streaming audio metadata over IP. Now, in modern applications, in modern audio applications, we have the need for sending over object-oriented metadata or metadata in general to allow immersive audio applications and enhanced surround and even other applications which require metadata. And by now, we only had the option to transport metadata within AES3 audio streams. As you all know, AES3 is not compatible with AES67, as AES67 only covers the linear PCM audio, but AES3 allows the transport of additional metadata inside the audio stream, and that AES3 metadata cannot be transported with AES67. Luckily enough, SMPTE 2110 addressed that within their scope of work, within -31 standard, which basically is built upon Ravenna's AM824 transport profile. But even with that AES3 bit transparent transport, we only have a limited amount of metadata which can be transported, and it needs to be encapsulated in a particular audio stream. Now, the idea of X242 is to transport the metadata as a new individual or independent essence stream, which can have some alignment with the related AES67 stream, so that we are free of the limitation of the amount of metadata, and that we don't have to encapsulate it actually inside the metadata, so that reception of audio metadata can be done upon depending on the particular needs of an particular application. So of course we have to talk about synchronization, the RTP media clock and payload format, and how those streams are associated or aligned within AES67 streams. And luckily enough, we seek very early for a collaboration with the SMPTE 2110 group, because the -41 document, which is currently in the works, also covers the transport of what they call extensible fast metadata. So that definitely goes beyond the needs of audio, but it also includes audio. So we are aligning our work in the AES group with the SMPTE group, so we don't end up with two competing standards here. So talking about SMPTE 2110, the other big important standard in the media over IP scene or market is 2110, which basically specifies a suite of standards which cover transport, synchronization of separate elementary essence streams. So video, audio, and ancillary data and everything else is transported as independent media data streams on managed IP networks at any speed. So that definitely excludes, just like AES67, any unmanaged network, particularly like the internet. And the target applications are real-time production, playout, and other professional media applications. Now, you might know that already, of course. The standard consists of a number of documents. The 2110-10 covers system timing and definitions. -20 describes how uncompressed raw video is being transported in an RTP essence stream. 2110 talks about the necessary traffic shaping when transporting raw video streams. You know that raw video streams, uncompressed video streams, can consist of quite large amount of data, or requires large bandwidth, and of course in certain network environments, particularly when we want to transport multiple of these streams, we need to make sure that there's a nice traffic shaping in place, so that we don't overload switch buffers and of course receiver buffers. So traffic shaping is another document. -22 document describes how compressed video is being transported within 2110. It's not mandating for a particular codec. It's just explaining how any encoded compressed video is packetized signalized and transported with respect to the system timing of 2110. Dash 23 discusses high bandwidth video, so you can imagine like high frame rate video or even large resolution videos like 4K, 8K. They might not fit into a single stream. So Dash 23 describes how to actually separate high bandwidth video streams into individual video streams, which are then again fully Dash 20 and Dash 10 compliance, and describes how a receiver can reassemble the full high bandwidth video from the individual part essence streams as described in 23. So then for the audio side of things, Dash 30 basically describes how to transport linear PCM audio, and folks at SMPTE were very wise by referencing back to AES67. So basically Dash 30 mirrors what has been written or set forth within AES67. Likewise for Dash 31, which covers the AES 3-bit transparent audio transport. I just discussed that this is not part of AES67, so there's another an individual standard document for it. That is fully based on Ravenna's AM824 format. So everyone who has implemented Ravenna with the AM824 format is already fully compliant to SMPTE's 2110-31 standard document. Then we have the Dash 40 document, which covers the SDI ancillary data parts, which are part of a standard SDI signal, but do not relate to audio or video. So any metadata which is usually transported in the horizontal or vertical blanking intervals, that is being transported as an individual essence stream in Dash 40. We have the Dash 43 document as the news release document, which is about time text. And there are much more documents to come. And if you want to dig into more details, again, SMPTE has a nice page with frequently asked questions at SMPTE.org. And from there, you will also find pointers toward the individual documents. And again, the Ravenna website also offers some insights. So what is currently under development inside the 2110 group? The Dash 24 document is a recommended practice document, which describes how SD signals will be transported within the SD2110 environment. 25 is a recommended practice document about the system timing and definition. So it highlights the nomenclature, the formulas, the explanation of system keywords, and so on again. So it clarifies some ambiguities or questions which might arise from the Dash 10 document, or which are not clearly enough defined in the Dash 10 document. And then again, I also mentioned that as well, the Dash 41 together with the Dash 42 document, which is about extensible fast metadata transport. So that is basically the standard describing how any related or even unrelated metadata of any sort can be transported without the restrictions, which typically are found within the AES 3 or an SDI, horizontal vertical blanking interval. So that is an independent work, but again, it's aligned with the work within the AES-X242 group. Right, so what else is currently in the work? All the documents I just mentioned, except for the Dash 30 document, which is the AES67 document, right, or the reference to AES67. All of these documents are currently in a one-year review process. After publication, which mostly happened in 2017 and 2018, every document automatically goes through a one-year review phase. And if people find that there's something needs to be amended or changed in those documents, they automatically go into review. And these documents are currently under review, but most of this is already done. Another piece of work is EPIX, again, similar to AES67. SMPTE is defining a PIX document, protocol implementation performance statements for for the various 2110 subdocuments. 2159, the PTP profile definition for 2110, is also in a one-year review, and also this is almost done. The most noticeable work you will see once published is that there was an ongoing discussion about insensitive or offensive terms in relationship to PTP. You all probably know that in PTP we have master and slave clocks defined, and most of the participants, most of the industry actually, particularly on the other side of the ocean, so on in the US and other related areas, they found that these terms are inappropriate. And so they were seeking for a replacement of these terms. So they concluded on replacing master and slave with the terms leader and follower. So that would be one of the major changes in 2059. They also discussed if they need to relate an update to the new PTP version 2.1 document. But as you can see later, there was not really a necessity to actually update the reference to the PTP document. So 2059 will still refer to 1588-2008. There's further work in relationship to PTP. We have a security study group and a data model and semantics for PTP monitoring purposes. That is also related to 2059. So if you're interested to learn more about PTP, I can highly recommend to tune into next week's Ravenna webinar, which is on PTP, in particular, of course, standards updates and best practices for PTP over wide area networks and reliability. And the presenter will be Daniel Boll from PTP manufacturer, Grandmaster manufacturer Meinberg. So note that down. 1 week from now, PTP as a topic of our Ravenna webinar series presented by Daniel Boll. Related work, which relates to 2110, is executed in the Video Services Forum. It's another industry alliances. There's currently work going on how to transport 2110 over WAN, over wide area networks, very similar to what we have done in AES. But they're also talking about discussing and releasing technical recommendations about RIST, so securing RTP transport over wide area networks, and cloud-based operations, ground to cloud and cloud to ground interfaces. And as indicated earlier, also IPMX large parts of IPMX are executed by VSF, and I will give you an overview on IPMX at the end of this presentation. Okay, another big topic is the PTP standard itself. So this is maintained by the IEEE. And as you all know, we are currently using PTP version 2.0, which has been released in 2008. And it took them 11 years to come up with a new standard, the PTP version 2.1, which was published in 2019. Actually, it was published in 2019, but it was finished in 2019. It was published early 2020. But since the standard standard work finished in late 2019, it's called 1588-2019. Now, we all know that we have an issue with backward compatibility between PTP version 2 and PTP version 1, which was released in 2002. So the question is, so what about the new PTP version 2.1? Will it break anything within 2110 or 2059? Big question. Well, I can tell you, don't panic. We have full backward compatibility defined within 2.1 with respect to version 2. Not with version 1, of course, but full backward compatibility with version 2. So what does that mean? Well, the bylaws already define that everything the work group is defining shall ensure that we have full backward compatibility with the previous edition of 1588. And what does backward compatibility mean? Well, any PTP version 2.1 devices, and that applies to leaders as well as followers, will work in an already existing PTP version 2.0 environment and won't compromise it. All the version 2.1 features are optional, so none of these features which have been introduced in 2.1 are mandatory, and anything within 2.0 works as before. So what are the new features introduced in PTP version 2.1? And I won't go into detail, just giving you a group-wise overview. We have features which enhance the flexibility, the applicability of the protocol, of the PTP protocol. A majority addresses features which increase the robustness of the PTP protocol, and also for mostly for science applications, there was a requirement for increasing the accuracy. As you all know, PTP version 2.0 can have an accuracy which goes into the double-digit nanoseconds range. For some science applications, they needed sub-nanoseconds accuracy, and so there were some features added for increased accuracy within 2.1. Again, the advertisement. Next week, Daniel Bohl will explain some of these features and how they are applying, or if they are applying at all, to our media applications, to AES67 and 2110. So next big chunk of important work is executed by the Advanced Media Workflow Association, the AMWA, in particular the NMOS, the Network Media Open Specifications. So NMOS, most of you should know that by now, is a family of specifications which go hand in hand and coexist and enhance the functionality of the transport specifications like 2110 and AES67. Again, 2110 and AES67 address transport, and NMOS goes beyond that. It's adding functionality on top of the transport standards. So at the moment, we have some stable specifications within NMOS. The most important, or the most applicable to our applications, certainly are ISO 4, which describes discovery and registration of nodes and their system resources. ISO 5, which defines ways of connection management. So how can receivers connect to available streams? ISO 8 discusses audio channel mapping. So how are discrete input channels mapped into a transmitter stream, or how are channels contained in a received streams, how are those mapped to available output channels on a receiving device. ISO 7 event and tell specifications, so that is more about the functional side of things, so that a current status or status change, like, a button has been pressed, or a stream reception has been canceled, or whatever. So whatever you can imagine as status change can be communicated from senders to receivers, or from any node to the registry in general. Then we have a number of best common practices. That's why they're called BCP. So there are practical recommendations. One touches on how flows relate to each other. So if you have, let's say, 2110, which has individual essences as video, audio, and story data flows. So this one describes how you can identify flows which relate to each other. Then there's a big group of specifications and BCPs which touch on authorization and security. So how can I make sure that only authorized nodes are part of the whole NMOS communication infrastructure? How do I secure the access and the communication between any participating parties? And there's much more in the works. And for those of you who are interested in reading more on the details, here's an overview of what is currently going on in the NMOS open specification working groups. We have those existing specifications, ISO 4 and ISO 5, which have both produced updates. So the original specifications were updated and have enhancements defined. You all see the URLs of the repositories if you want to learn more, want to dig deeper into individual topics. These are the URLs where all the information about the individual specifications or BCPs are stored. The latest specifications we have seen coming out of NMOS are IS 9, 10, and 11, which talk about system parameters, authorization, and sync metadata or receiver metadata processing. The best common practices have been specified recently. Another one is in the works, the edit to receiver capabilities mapping, that is particularly useful for the IPMX work, which I'm explaining a little bit later. And NMOS is also releasing informational documents which further explain or elucidate about certain areas of interest, like an security implementation guide or implementation guide for the DNS-SD, which is required for the ISO4 discovery and registration functionality. And there's more in the works. And as always, if you're interested in this topic, overview and introduction to NMOS can be found on nmos.tv, and the technical specifications, the details can be found on GitHub at the AMWA-TV GitHub, and there's also a wiki which explains the most important terminologies. So that is NMOS, and just to give an summarizing overview again, how 2110/AES67 and NMOS relate to each other. SMPTE addresses all the transport protocols and definitions, so how the system timing, the video, the audio transport is actually achieved, and NMOS adds on top of that with network transparent application programming interfaces covering upper layer functionality like registration, subscription to streams, the channel mapping, authorization, and so on. So these two, standard and specifications go hand in hand and extend the functionality toward real systems. Talking about real systems, there's yet another organization coming into game, and that is the EBU, the European Broadcasting Union. The European Broadcasting Union has specified in a document, in the TEC 3371 document, which again also has an update, received an update in 2020. It specifies the minimum requirements to build and manage a full IP-based media facility using all these open standards and specifications, and of course also specification standards beyond SMPTE, NMOS, and AES. So on top of the pyramid, we have media transport, which is basically all the SMPTE 2110, AES67 stuff. Then the next level is all things related to the timing and synchronization. For example, how do I achieve PTP redundancy? How do I work with SMPTE and AES profiles hand in hand? And further topics are discussed in that area. Then operational control is another layer in the pyramid. So beyond transport, of course, I need to configure devices, talk to devices, control devices. So operational control, as you can see, most of this is based on NMOS specifications. The next level is configuration and monitoring. Of course, you need to have the ability to fully configure devices when they enter a network, and that goes certainly beyond ISO4, and they can only work once they have received very, very basic network configurations like IP assignments and other things. So this layer also talks about what are the basic configuration and monitoring functions which are required to build a fully working system. And last but not least, the security layer. There are some EBU recommendations for touching on security, as well as the AMBER BCPs 003 come into game. And all this, this is just a visualization of all of this which is being discussed and set forth in the EBU TEC 3371 document. And that one is available, publicly available, openly available from tech.ebu.ch, because EBU is hosted in Switzerland. And just a final word on the colors. The colors indicate which functions or how much of these different function layers are already addressed and also implemented or available in standard industry implementations. As you can see, going from top to down, on the basic levels, we have basically everything implemented and available. Most of the timing and sync is available. Some of the operational control is available. Some parts are still open or proprietary. Same is true for configuration and monitoring. And when it comes to security, well, we still have quite a lot of work to do in order to come up with a common rules and guidelines how to work securely or how to provide security in these kind of environments. So that is the work of EBU, and as you can see, all this goes hand in hand together with SMPTE, AES, AMWA, and so on. Well, and up to now, I've been talking about the broadcast applications, the professional broadcast applications. So all of this originates and mostly applies to the requirements of professional broadcast applications. Now, there's another huge market, a huge area where we need audio and video distribution, and that is called Pro AV, Professional Audio and Video Market. As I said, all these standards which I just discussed are mainly targeting the broadcast applications. So the question sure is, so what about Pro AV? What is going on in Pro AV? And can any of these functions maybe even apply to the professional audio video market? Now, if we look at the current landscape in Pro AV, we mostly see proprietary, or what I would say marketing standards, which are currently available in the Pro AV market or have predominance in the market. And that for sure includes NDI, SDVOE, Dante, as well as a huge deployment with the HDBT-based installations. So these are the predominant, mostly proprietary standards which are currently seen in AV. And again, the same question is, can any of the open standards and definitions which are currently emerging in the broadcast side of things also be applied to Pro AV? So what would need to happen in order to make them also applicable to Pro AV? And first of all, the IPMX has been inaugurated by AIMS. It's a new initiative of AIMS. Well, it's not new anymore because it has been inaugurated in late 2018, early 2019, and from there on, some work already started, and we are already seeing some initial IPMX implementations. So first of all, what is AIMS? For those who haven't heard about AIMS yet, AIMS is the Alliance for IP Media Solutions. It's basically a non-profit trade alliance which is open to everyone. Funding is solely done by member fees, so they are not receiving any other money from other organizations or other sources. And within AIMS, all members share a common goal, and the mission of AIMS is, of course, to foster the adoption of one set of common standard-based protocols to achieve interoperability over IP in the media and entertainment industry for professional audio-video applications. AIMS members are companies, manufacturers from the broadcast industry, but also major broadcasters like BBC and others, Disney, which are all gathering under the hood of the Alliance for IP Media Solutions. So here's a quick view on who is currently member of the AIMS. Going through this list, but you can identify some very large organizations like Disney, like NBC, and on the other side, some very well-known manufacturers' name. So the idea is to provide guidelines for the standardization organizations and other alliances, what functionality, what requirements are needed to actually build unique interoperable system based on open standards. So AIMS has published a roadmap how this goal can be achieved. So first of all, of course, we have these old standing SMPTE 2022-6 standard, which basically defines how SDI is transported over IP. So that is the basically the multiplexed audio, video, and serial data signal, which is then encapsulated as a single stream. And this has been used throughout the industry for contribution between various production facilities. Then, of course, AES67 is part of the roadmap. AES67 has adopted for the audio transport. 2110 has been adopted onto that roadmap. And there are additional functionalities which are available through other standards which are described in the JTNMTR 1001, which basically reflects what is being provided by the EBU tech doc, which I have explained a little bit earlier. So this is the valid roadmap is a quite long-standing roadmap of AIMS. It hasn't changed until October 2019, so it's very stable up to now. Speaking of the professional broadcast environment, now how does it all apply to the Pro AV market? Coming back to IPMX. So the idea is that for the Pro AV market, we need more functionality than what is defined in 2110 and NMOS. So we need additional functionality, which is provided by, by this HDMI connector. So inside an HDMI connector, we have functions and protocols like HDCP, CEC, EDIT, HDP, USB, and even more. And so all this would be needed if we want to replace HDMI with an IP-based approach. So the idea basically is to take the best parts of 2110 and NMOS and the requirements provided by HDMI-based connections and squeeze all that into a new specification, which is called IPMX, the IP Media Experience. So from a very high-flying level, IPMX is there to define a set of common, open, and standards-based protocols for interoperability over IP for the Pro AV industry. So that sounds very, very similar to what is has been defined for the AIMS mission. We know that within the realm of IPMX, we need compressed as well as uncompressed video, audio, and metadata. Mostly compressed will be needed in addition to uncompressed, which is already there defined in 2110. And we also need provisions for control, connection management, copy protection, security, which needs to be part of IPMX. And then naturally, because it's initiated by AIMS, IPMX should be based on the already existing and proven AIMS roadmap. So how does that translate into the roadmap? So we have the vital part of the AIMS roadmap. So that's AES67, 2110. And we need additional functionality for the Pro AV standards or Pro AV market. And so we take the compressed video part. We have JPEG XS as a recommended video compression or video compression codec, but that's not, of course, the only one which is applicable. Discovery, registration, connection management as provided by NMOS, ISO 4 and 5, and we need edit and display ID and so on support. All these functions are definitely required and are part of the proposed IPMX roadmap. And then we have some additional functionality which may not be required under all circumstances, but are nice to have, or in some applications they need to be in place, like the HTTP copy protection, general purpose I/O, audio channel mapping, and so on. All these are also added to the proposed IPMX roadmap. And while this work is already in place and already published, most of this is in the works. Well, we have ISO 4, ISO 5, which is published, the 22, which is published, but we are currently also revisiting the definitions and see if they need any enhancements. And so all the work which is listed up here, which needs to go into IPMX, is actually a collaboration between AES, SMPTE, AMWA, VSF, Video Services Forum. So it's not one single organization who is trying to define these additional functionalities and how they are, translated into standards or best practices or whatever. It's a collaboration of various, or share of work between various standard organizations and industry alliances. So this is really an interesting approach to look into the topic on how we can provide a set of open standards for IP-based transport and functionality for the Pro AV market. If you want to learn more about IPMX, just go to the their special website, which is provided by AIMS, IPMX.io, and you'll find much more information on the status of IPMX and what is currently going on, and some early existing implementations. Now, looking at the time, I'm sure that you definitely are a bit tired by all these various acronyms and organizations, everything which was mentioned within the last 45 minutes. So here's my final set of slides, which describes how all these standard organizations and industry alliance relate to each other. So this is what I've been talking about. Some in more extent, some others were just mentioned as side notes. But here's a slide which actually tells you how all these organizations collaborate with each others and how they work hand in hand. First of all, EBU and Video Services Forum have gathered important user requirements. Those user requirements were fed into the JTNM, the Joint Task Force on Network Media, which consists of work groups from AMWA, EBU, SMPTE, and VSF. And they generated a reference architecture out of those user requirements. This reference architecture then has been taken up by the Video Services Forum, and they were trying to build documentation definitions, how you can transform the reference architecture in actual living systems. And they were looking into existing standards from other industry organizations or standard organizations like the IEEE, the PTP standard, SMPTE, IETF, transport protocols, RC3550 is of course another one, and AES like the AES67. These are just examples, right? How VSF draw from existing standards and was building technical recommendations. Technical recommendation 03 or 4, for example, are building the basis for what we know now as SMPTE 2110, but they handed those over to SMPTE, which were then designed to build standards out of this. And all this work was accompanied by AIMS through market-based advocacy and feedback. So AIMS basically did not do any particular technical work, but they gathered information and feedback from the market and fed that into the work of Video Services Forum and SMPTE during their active working periods. And of course, it's still ongoing process because it's not finished yet. Well, we all know what was the result of this work based on TR03 and 04, but there was even more in the reference architecture, which has been taken up by the Advanced Media Workflow Association, building finally the NMOS standard. So we have the SMPTE standard 2110, which was the result of this path, basically originating from user requirements through reference architecture, through technical recommendations. And the other path was AMWA, who produced the NMOS specifications. So that is an example how all these different organizations collaborate, interoperate, and work together. So there is no single isolated organizations doing some work. They all work together hand in hand. That's just as an example, an overview, how the work is executed within the wider industry. All right, so that should conclude today's overview of what's going on and important and relating standard and industry alliances. And now it would be time up for questions. And I would like to bring in Roland, who's helping me observing any incoming questions. So Roland, what has been coming up in the Q&A section?
Hi, Andreas. Yes, thank you. Great webinar. We've got a question from Massimiliano here, who says, is it possible to embed X242 metadata into AES67 streams?
Well, the idea of X242 exactly is not to embed it into AES67 stream, but to set up independent essence streams. So that's just another flow similar to the way AES67 works with, timing reference, media clocking, and so on, so that a receiver can receive both streams individually. So it can receive the audio objects, the pure audio object information through AES67 streams. And then it also receives the X242 media data stream. And through interrelating the describing metadata to the actual media data, to the audio objects, it can then render the necessary, required, or intended output depending on its current rendering situation. We had an example. Unfortunately, I didn't have the slide at hand, but we had an example on, well, when shows actually happened to happen. At IBC 2019 and NAB, we had an example on how this can work together with Ravenna partner Dolby, where we had the audio objects being sent with AES67 streams, individual AES67 streams, and the metadata being sent out with a -31 stream, but only the metadata without any audio data. And then the renderer took the AES67 stream and the -31 stream, just with the metadata, and then it rendered the audio objects according to the information in the metadata stream. So we would not, encapsulate or mix or whatever metadata with AES67. That can already be done to a certain extent with -31, AES3, but we will have independent streams which are living side by side on the network, can be distributed as required.
Okay, that makes sense. I've got a question. You have the overall ST2110 initiative. It is supported by AIMS, and you have IPMX. Is there any detail on any compatibility between, if you like, the ST2110's implementation in the broadcast world with IPMX? Is that known yet? Is that established? Whether you could plug an IPMX stream into a system?
Yeah.
Or
so IPMX is still, of course, in the works, but the most recent work in Video Services Forum was actually addressing how 2110 and IPMX interoperate with each other or are based on each other. And actually, it looks like we will have a definition or requirement that any IPMX device fully supports 2110. So that means if an IPMX device, which is built according to the specification of IPMX, works within a 2110 broadcast environment, it is fully compliant. On the other hand, an IPMX device can also work outside of a fully synchronized 2110 environment, like in a typical situation where you just take an asynchronous stream in from a camera or from another feed, HDMI feed, let's say, just transport it across IP, and then a receiver will output the very same signal, but asynchronous to the whole system. Now, if that is the case, the situation, which we found in most applications, which we'll find in most applications actually, then an IPMX device has exactly this specification to support this. So basically, the interoperability is based on the 2110 specifications, but IPMX goes beyond that by fully supporting the asynchronous operational case as well.
Okay, that makes sense. And unless there's other questions coming in, I have one other question. Is you've mentioned it, I think briefly already, but if you could give us a bit more details about next week's webinar, please.
Oh, yes, all right. Okay, if there are no more questions regarding, well, this somewhat dry topic of standards in organizations, so on, I think it's important to sometimes, have an overview update on what is currently going on. I'll have a final slide on where you can find answers to all your questions you might have, or where to look if you want to dig into more details. So all these mentioned organizations, of course, have their related websites where you can gather more information. So as this is part of the recording, I don't have to keep this slide on for now. I just want to mention that you'll find quite a lot of information also on the Ravenna website. There are special sections on AES67 and 2110, and of course there's this huge resource section where you can find quite interesting information, not just on Ravenna, of course, but also on the most relevant standards. And I also encourage everyone to subscribe to our Ravenna newsletter, which is sent out, let's say, every 2 or 3 months, not more often, but then you stay in the loop for any upcoming information. Yes, and actually next week's webinar is, as I mentioned several times, on PTP. It includes a small standards update, of course, but also Daniel Bolt from IPMX will talk about best practices on how to transport PTP across wide area networkings, and also how to make PTP operations more reliable and more secure. So I just can encourage you to tune in to next week's webinar, 24th of November, same time, 1700. And as always, you can register on the Ravenna network for this webinar. Well, no more questions coming in, or is there more questions, Roland? I see some things in the question area.
There was just one more question about where to find recordings of all the webinars, and they're available all on the Ravenna website.
Absolutely. Just go to ravenna-network.com and you will be guided to where you can find the recordings. They finally end up, of course, on YouTube. So we also have a Ravenna channel on YouTube. So that's where you will also find the recordings of these webinars. And I think we even provide a PDF version of the slides so that you can read all about it without having to rewatch the video again. All right, just in time. Very unusual for me, actually, but yeah, just in time. So I thank everyone for bearing with me today. This is really the very, very final slide. Feel free to get in touch with me. You can contact me at any time at ravenna@alcnetworks.de or through any other means provided through the Ravenna website, and hope to see most of you again next week when Daniel Bolt is talking about developments and best practices with relation to PTP. So thank you, everyone, and have a good rest of the day, or well, a good glass of wine or beer if it's already in the evening hours. And goodbye.